All right, so I want to go ahead and start making our item classes a little more useful. Right now we have this rotation, move speed stuff, and we have lifetime. But I want to make these items so they bounce up and down. So they go up and then back down and then back up and back down. And let's do this infinitely. We could program this where we track how far it moves, then it reaches a certain point, go back and then track how far it moves and then go back. But we can actually do this mathematically a lot simpler using some trigonometry, specifically sine. So with sinusoidal movement, we have a wave that goes up and down where we have our height and our max height up and max height down where the same values are the same. And it has to do with the radians in a circle. We're not going to worry too much about the math. Just know that this sinusoidal movement is consistent. You end up with a wave. And if you track where we have our height by time along x, we can make it so the movements go up and then back down really easily. So if we go back into our item.cpp, I'll take our add actor rolled rotation. Let's go and delete that. And I'm going to add in float delta z equals, well, what do we need? We need the amplitude. The amplitude is how high we'll go up and then down as well. So I'll do, let's do 10 f times f math, which is a class we have access to inside of Unreal, sin, S-I-N, or sin. And then we'll take the lifetime times our move speed. Now, again, I told you I wasn't going to get too much into the math of this, but just know that the speed of our movement is defined by how long the thing's been existing times how fast we want it to actually move. We then take this delta z, right? And then we can change our add actor world offset where we want it to move along x by 0, along by y by 0, but along z by delta z. Save that and let's go compile and see what happens. Right now, if I go and press play, they are there and they're bouncing way too aggressively. And they're also not really moving all that much. I want to move some more. So let's go and change this. So first off, the amplitude, how high it's moving, this really should be its own variable. So I can do variable. In fact, I'll just copy and paste because I don't really want to do it myself. And instead of move speed, I'll call this one amplitude. And I'll write a comment, amplitude equals how high it should move. And I'll go ahead and change the move speed to 10 for now. And then inside of where I'm doing that math here, I'm going to change this to be amplitude. Now, because we set the amplitude to be blueprint read write in the category of movement parameters, once I compile this, I can actually go ahead and edit the values if I want to within the game engine without having to worry about the code anymore. Let's test to make sure that this works first. Press play. Oh, it's there, but it is moving way too much. Okay. Well, because my amplitude is left at 50 because I didn't change that. But as I said, we want to modify it within the blueprint. So I can now go into my BP item class defaults. I can change the amplitude to be, let's say, 10. And the move speed to be 5. And I can run this. Right, 10 is still too much. So I can go back and again change it to be 5. And there we go. We now have objects that are bouncing Bobby up and down. Maybe still a little too much for what I want it to be. So I'll change the amplitude to be 3. I want to go a little faster, so I'll set that to 7. And there we go. We now have things that have movement that could easily be its own little item that lives in our game. Now, this code that causes it to bounce up and down, let's say we wanted this to be reused in multiple times. Well, we can go ahead and just make this a function. So a function being a set of code that you can repeat multiple times. So I'm going to go into my .h. I'm going to delete rotation speed. We don't need this here. Instead, what I'm going to do is I'm going to create a function called float. Let's call it sine movement. And we just want to pass in time. So float time. And then I want to create that function within my CVP file. So here above tick below begin play, I'm going to create that function. I'll do float. It's going to return a float. A item colon, and I'll do sine. What did I call it? Sine movement. Yeah, sine movement. The parameter of float time. And then we can just take this, all that math, copy, paste, and put return in front of it. So this will do the math here, then return that value for us. So I can delete this down here and set this to be sine movements, and I pass in lifetime. Let's run this to make sure it still works. And it still does. Great. But this function is only usable within our C++ class. What if I wanted to be able to change it and edit it within Unreal? Well, luckily for us, we get access to another set of macros, this one being UFUNCTION. And in this case, I'm going to set a category to be movement parameters again. But I'm going to make this one blueprint callable. Now, there are two different kinds of things we can put here: blueprint callable and then blueprint pure, but we'll worry about that later. So now, if I take this and run and compile, I now have access to sine movement as a function here. So I can set event tick and connect this here. Actually, I made a mistake. So in this function, I don't need to pass in time. So I can get rid of that parameter. I don't need this here either because our function pulls the lifetime automatically for us. So try that again. Oh, and I don't need this here either. So I removed those parameters from that function. Try this one more time. There we go. So now I have my sine movement. I can use this and I can set add actor world offset. I can set the value of my sine movement to, well, let's go ahead and right click delta location, split struct pin. So we set the bouncing up and down to Z. What if we wanted to move left and right? So I can set that sine movement to delta location Y. Press play, and now it moves up and to the side, so it's moving at an angle. So I wrote this function in C++, and I can use it within Blueprint. But this is actually an instance where we wouldn't use Blueprint callable. This is the most common version of this that we'd use, but I don't actually want this to be Blueprint callable. I want this to be instead Blueprint pure. Now, a pure function is one that does not need any input or whatever. It just does some calculations. So I take this and compile. Actually, I need to delete this first. Oh, it'll give me an error. Now if I compile it and check. Now if I do assign movements, there's no execution pin. It just returns a value. If I had input, it would give me access to that, but I don't have that here. I can now just connect this to delta location Y, connect the execution pin directly from event take to add actor world offset, press play, and it works. So we get a lot of power just from writing our code in here using basic math that we can reuse all over the place simply by using the built-in uProperty and uFunction macros. For the end of this video, I'm going to go ahead and delete this blueprint operation here. I just wanted to bounce up and down, which we handled in our code here. We might move this out later, but for now, this should do. All right, thanks.